Hi, and welcome to this quick review of naming alcohols, looking at their structure and their properties. Before we start, make sure you've got your notes or independent study materials with you because the clip is designed to go with them as opposed to replace them. So the first experimental work you might have done on alcohols might look something like this in terms of using them as fuels, which would suggest that they have relatively high enthalpies of combustion, so are good for this particular application. But it might be interesting to think about why this might be in the first place. So the thing about all alcohols is they've got at least one OH group contained within the molecule. So that OH group means they can undergo hydrogen bonding with each other and also with water. So we tend to find that smaller alcohol molecules can mix easily with water, they're soluble in water, and also have higher boiling points than the equivalent alkanes or alkenes, due to the hydrogen bonding, of course. So alcohols are classified as primary, secondary, or tertiary, depending on the number of carbon-based groups bonded to the carbon atom, which is bonded to the OH group. So let's look at what this means. I've highlighted the carbon that is attached to the OH group in each of these molecules. So looking at primary alcohols first, they have one carbon-based group attached to the carbon that the OH is attached to. The exception to that rule is methanol. It's the only alcohol that doesn't have any carbon-based groups attached to the carbon that's attached to the OH group. So I've circled the carbon-based group that's attached to the carbon that has the OH group attached. So you can obviously see what's happening with a secondary alcohol and also a tertiary alcohol. The secondary alcohol has two carbon-based groups attached to the carbon that the OH group is attached to, and the tertiary alcohol has three carbon-based groups attached to the carbon that the OH group is attached to. So as you can see by the naming, the normal systematic naming process applies. IUPAC stands for International Union of Practical and Applied Chemists, and it's the normal system we use in A-level chemistry and beyond. So obviously you've got ethanol, propan, 2-ol, and then 2-methyl propan, 2-ol. So another example might be pentan 3-ol, for instance, or 2-methyl propan 1-ol. So these would be simple examples that you'd be expected to handle. So this is now a cyclic alcohol where a hydrogen atom on cyclopentane has been replaced with OH. So the carbon atom to which OH is bonded is assigned locant number 1. So following the main idea of keeping the locant numbers as low as possible, you'd now call this 3-methyl cyclopentanol. So this one would be cycloheptan 1,2-diol. So a diol obviously has two alcohol groups, a triol would have three alcohol groups. So each OH group would get its own locant number depending on its position within the molecule. So this can be applied to normal straight chain alcohols, not just cyclic ones like this. So let's have a quick look at an exam question that covers some of this stuff we've looked at so far. So let's have a quick look at this question. The general formula of a member of the alcohol homologous series. Notice that all the structural formulae have OH in them. So by including the functional group within my general formula, I put CnH2n plus 1 OH. So in the molecular formula, because they asked for it by name, I can put C13H28O as opposed to C13H27OH, but they'd probably accept C13H27OH. So the next one asks for what a functional group actually is. So something along the lines of this would be fine. An atom or group of atoms which determines or controls somehow the chemical reactions or properties, chemical properties that is, of a compound. So let's move the page down a bit. So as we go down, we can see there's another question we're being asked. This time it's a 3 marker. And I'm going to put 3 bullet points for this one. This is to help me sort of split my answer into three sections. So it says at room temperature and pressure, the first four members of the alcohol homologous series are liquids, whereas the first four members of the alkanes homologous series are gases, and it wants you to explain that difference. So the first thing is to make a comparative statement about alkanes and alcohols in terms of their intermolecular forces, because that's what's going to determine the boiling points. So alkanes only have London forces, but the alcohols also have hydrogen bonding, and the hydrogen bond is stronger than London forces. So therefore, there's more energy required to overcome hydrogen bonds. So the next thing is about methyl propan-1-ol and butan-1-ol. They're structural isomers, so it means they've got the same molecular formula. So it can't be down to different molecular sizes that methyl propan-1-ol has a lower boiling point than butan-1-ol. So the first thing to state is methyl propan-1-ol is more branched than butan-1-ol. So therefore, methyl propan-1-ol has less surface contact points for London forces. So the next question is asking you to write complete and incomplete combustion equations. This is no different to the complete and incomplete combustion of alkanes that you might have looked at already before starting your work on alcohols. So taking the first equation as representing the production of carbon dioxide, we end up with this, and the second equation, which would represent the production of CO, would look like that. Now notice, obviously, I need to take into account the presence of the oxygen in the actual methanol molecule itself when I'm doing my balancing. Now for the incomplete version, you could obviously also include an equation that just has carbon being produced, or some carbon and some carbon monoxide. So other alternatives are possible for incomplete combustion, provided it's balanced and provided there's no CO2. Now obviously there's less oxygen in carbon monoxide than there is in carbon dioxide, so the next question is fairly obvious what's happening. There's not enough oxygen available, and that would cause the incomplete combustion problem. So, moving the page down, it says, in addition to its use as a fuel, methanol can be used as a solvent and as a petrol additive to improve combustion. Then it asks you for another large-scale use of methanol. So in these kind of questions, if you don't know what else to put, it's perfectly safe to put something like organic feedstock. A feedstock is a compound that's used to make other compounds in industry. So methanol is commonly used to make other compounds in industry. So this will do. You don't have to say specifically what. Now the butan-1-ol, unless you've been doing work on oxidation of alcohols, this is actually not getting a little ahead of ourselves for this particular clip. So I'm going to leave the butan-1-ol one for now. When you come back to alcohol reactions, this particular one will make a bit more sense. Now in this final part of the question, I'm not going to bother with part II because that's talking about the chemistry of the oxidation reactions as well. So for now I'm just going to do the top one, where it says write and name, then draw the structure of the structural isomer, of C4H10O that is a tertiary alcohol. So I start by drawing my COH, and to that carbon I need to put 3 carbon-based groups. But I've only got 4 carbons to play with, so I'm not going to add any more carbons onto any of them. I'm going to add hydrogens on instead. So I need to check now, do I have 10 hydrogens? Yes, I do. Do I have 4 carbons? Yes, I do. Do I have 1 oxygen? Yes, I do. So this is one we looked at a little bit earlier in the clip. So for this one, we can go for 2-methyl propan 2-ol. Or we could just call it methyl propan 2-ol, because let's face it, where else is the methyl group going to go apart from carbon number 2? Okay, so that takes us to the end of this clip. Hopefully it's been a fairly useful introduction, and it shows you how some basic ideas about alcohols come up in exam questions from time to time. So until next time, thanks for listening, and see you soon.